Do you want to fully automate your Bambu Lab A1 or A1 Mini for free using only stock parts and your slicer? Great, because in the following minutes I will show you all of my automation secrets, like print looping with 3MF files, safe ejection for small and big parts with next level self-release science, and many more exciting tricks together with slightly amusing jokes. Let's get right into it by understanding the automation process. We have a startup sequence, printing the model, the ejection phase, and looping everything to start again, all in the shape of one convenient 3MF file. We'll begin with the startup sequence. The A1 series printers do quite a few actions which are inefficient or unnecessary, and my inner German urges me to optimize that. So let's modify the start G-code. Click on Printer Settings and go to the Machine G-code tab. This interface is a pain to work with, so just copy all code into a new text file and open it with your favorite text editor, like Notepad++ in my case. We will briefly go over what to comment out for the A1 Mini and the very similar A1. Roughly understanding these G-code parts is important, so don't skip it. But all files for both printers are also free to download below. Let's start with commenting out the vibration check by adding a semicolon in front of each line. In Notepad++, you can multiply your cursor by pressing Shift, Alt and down arrow. Doing this vibration check before every print is unnecessary, and your neighbors will finally stop wondering why you are drilling holes into your floor on a Sunday at 2 AM. Just make sure at least one M975S1 command is enabled afterwards to load the last compensation values. Do the proper calibration through the printer's menu every few months, or when you move your printer to a different location. Be extra careful not to comment out the G1 move command that raises the nozzle to not hit your print bed in the process. For the A1, we can just comment the whole section out. And don't worry, the M975 command is still there a few lines below. Since we will be using 3MF files, our printer politely asks if we want to run the leveling sequence before each print. So we can just leave the whole G-code section in. I still only do this occasionally, but this is of course up to you. Next up are the annoying nozzle load lines, which can't be pushed off with the print. First, we will comment out the M109 nozzle heat command. This will make sense in a minute. One load line is between line 349 to 415, together with a dynamic flow calibration, which must leave and find new friends. This flow calibration should never be done in an automation setting anyways, as its results can be unreliable. It's always better to perform a K-value calibration manually through your slicer once and then add it to your filament settings. Another option to save the K-value is by adding the M900 command to the filament settings. For a more convenient setup, I recommend checking out Orca Slicer. Because we want to prevent any unnecessary nozzle leaking during the heat up process, we will split the heat up command into two parts. Let's change this to a M109 command to wait and heat up to target temperature. We will also decrease the target temperature by -20 degrees. The full heat up comes later, but we'll additionally enable the part cooling fan using the M106 P1 command to cool down the nozzle tip during the partial heat up. We will also comment out all G0 extrusion commands to disable the second purge line. No more of that unwanted filament sneezing on our print bed. Let's quickly do the same for the A1 by first commenting out the dynamic flow calibration, which confusingly includes both load lines. We'll also add a G1Z move command to raise up the nozzle. Like before, we turn on the part fan and include the partial heat up. If you try out the start code like this, you will notice that the nozzle is empty and it won't immediately extrude due to the missing load line. In return, the print bottom will look like it went on a diet and forgot to tell the rest of the print. Let's fix that at the very end of the start G-code by adding a G0 extrusion command to fill up the nozzle. Depending on your filament, E values between 1 and 1.5 should work well. But don't worry if this pushes out a little bit too much. Small pieces are mostly gone by the second layer, as the nozzle will just smooth over any bumps if you go slow enough. If we take a closer look at the print bottom, barely any defects are visible, and this is already an okay print. You can also push out a little extra filament during the first few moves to get a very reliable start. This will lead to a perfect print bottom as shiny as my bald head. We will add this in later. Another option is to add a little sacrifice piece to your model in the slicer. This can quickly be removed after the print. Look at my previous video for more details on this approach. All that's left now is to fully heat up the nozzle during the first few moves by adding the M104 command. This end section is the same for the A1, but your E values should be between 2 and 2.5. Our startup sequence is finally done. Now we just copy everything and paste it into the printer start section. Then hit save and give the automation profile a fitting name. Perfect. If you like that detailed type of content so far, press that like button, subscribe or comment below. The new optimized startup is faster and only does the essential commands. I don't recommend erasing any more parts. Be careful when you first try out your new code. Use an old build plate and nozzle in case something goes wrong. Let's continue with printing the model. We'll dive deeper into this topic later, but for now, I just recommend starting the print away from an outer wall. You can do this by adding a height range modifier from 0 to 0.2 mm and then adding more walls in that modifier. This approach will hide print start imperfections better. With that said, I've been very impressed with the print quality and reliability of the A1 Mini, which Bambu Lab sent me specifically to make this video a few months ago. I bought all other Bambus myself in the past, but thank you for the additional support. Let's continue with the ejection phase. All you need for this is the standard PEI sheet, which self-releases parts when they are cooled down sufficiently, leading to a safe ejection. Like earlier, we copy the end G-code into a text file for our modifications. First, we'll comment out all Z-move commands after the print is done. These are not needed for us. We will also change the nozzle parking move to the Y185 limit to be extra safe for the coming steps. By the way, this whole section works identical for the A1. The axis limits are just at X-48 and Y262. I'll show footage of both printers. Next up is the cooldown. Don't do this using a G4 wait command. Prints need slightly different cooldown times to self-release, depending on room temperature, model and filament. More on that topic later. But using a basic wait command might push your print head into a still adhering part, leading to pain and suffering for your filament pad. We will instead use the M190 command to wait until the bed reaches the temperature where your part self-releases and only weak adhesion forces remain. I recommend waiting until around 22 degrees Celsius, but this is up to you. Now you might say, this guy can't read his own code. But your printer will actually continue 3 to 4 degrees short of reaching the target temperature. So 18 degrees in this command equals around 22 degrees in reality. We will also leave a little extra space here to make our cooldown more efficient later on. The cooldown command will also be cancelled if the target is not reached after 90 seconds. So we'll do a big brain move and just multiply the command around 30 times for a maximum wait time of around 45 minutes, but you can add even more. We will also disable the heat bed afterwards just to be safe. With our part being cooled off completely, the ejection sequence follows. Our aim here is to use the X gantry and push at the upper part of the model to help with prints that may be a little stuck. We will add an automatic Z calculation for parts that are taller than 41 mm, which is roughly the height of the X gantry to the bed. Using this, even tall prints will be pushed near the top like we wanted. For small prints, we will go as low as possible by using the G1Z1 move command. But you can also use a basic G1Z move command to eject the part at any height you want, instead of this automatic calculation. We will also add the M400 command to make sure all Z moves are done, and then finally add the G1Y command to move the bed all the way back for a very slow push-off. For big parts like this planter, this works fine already, as the part just falls off at the end. But small parts like this egg cup are often not fully ejectable and stay on the bed. To fix this, we'll use tilt blocks to set the printer at an angle. This will help parts slide off the bed after ejection. This model for the A1 is made by Philpott, but for the A1 Mini, nothing like that exists. So I quickly designed one myself. Okay, who are we kidding? With testing, this took me a whole day. But now it only needs one screw, a fitting nut, and is easy to assemble. Make sure to use filament that keeps its shape under long-term tension, like carbon fiber PETG. I would also add some rubber material on the sides and bottom. Anything you have lying around works. A big rubber mat so nothing slides around is a good solution, but a small piece at the front is also fine depending on your table. Don't forget to run the vibration compensation once after adding this. By the way, all models shown in this video are downloadable below. A commercial license is also available on Thanks. All printer add-ons are free and in step format, in case you want to modify the geometry. Overall, tilting your printer is optional, but will help quite a bit, especially when printing multiple parts at once. For single parts on the A1 Mini, I recommend printing them as far on the right as possible. This will reduce the torque on the linear rail in case of a crash, but this is just a precaution. Due to the two linear rails, the A1 doesn't have that torque problem. Additionally, I would avoid using the 20mm on the left of the A1 Mini print bed, as you might hit the extruder during push-off. You can exclude this bed area in the printer setting with the shown inputs. If we now drag our model into the excluded area, we get a warning that this will hurt our little printer. This is again not needed for the A1, as the printhead is parked further to the left. With our main push-off complete, we will start the safety clear by moving the bed all the way forward again, and then moving the nozzle all the way down. Next, we continuously move the bed back in little steps. At every step, the extruder moves all the way to the right and then left again. We'll repeat the sequence multiple times with lower Y values until the extruder head has cleared the whole bed. This sequence will make sure that nothing is left on the bed at the start of the next print, and it can be used to eject small parts which are too low for the X gantry to hit. Ejecting multiple parts is also an option, but without a tilt block, this can get a little messy. I recommend adding some kind of protection to the side of your fan shroud when doing this. We are nearly done. We'll just add one more final print bed move to clear any lost souls away from the printer. Perfect. I also recommend commenting out the G1Z move command at the end. It is useless in our case. Now just copy the whole G-code and then paste it or my downloadable version into the end G-code section of your printer. Don't forget to hit Save Profile. If you slice your model with your new profile and activate all travel moves, you can look at the last layer to check out all printer movements in blue. This can be extremely helpful to check on your clearing sequence. By the way, there should never be any negative G1Z move commands shown here, as they would damage your printer nozzle. Let's continue with looping and sending our prints using 3MF files. In the slicer preview, we select Export all sliced file and hit Export to save the .gcode.3mf file. This is basically just a fancy zip file, which we can extract using software like 7-zip. If we click on the new metadata folder, the .gcode file can be modified. In here, we can search for the first few print moves around line 870 and slightly increase the extrusion values to push out a little bit of extra filament on the print start. This is what I talked about earlier, but of course completely optional. For print looping, we'll just copy the whole G-code and paste it in as many times as we want to print the model. It's that easy. Other looping commands sadly don't work on Bambu printers. Then hit the Save button and go back to the main folder. Select all files and turn them back into a zip file. Now we'll give the file an appropriate name and most importantly change its file extension to .gcode.3mf like it was previously. Here I just press yes, because I like to live dangerously. We'll open this file in Bambu Studio. It basically looks the same as before, but our print time has increased to 9 hours. If we look at the different layers, you will also notice that multiple egg cups will be printed on the same spot, with the ejection sequence in between. We can then send this file over to the printer and decide whether we want to level the bed or not. The auto refill also still works like it would normally. Alternatively, we can print this from the SD card and get the same type of print options. And don't forget to add some kind of box in front of your printer to catch all the ejected parts. This whole 3MF print looping works the same for the X1 and P1. But what about printing different colored prints or models in sequence? All we need for that is separate plates with our models placed on them. But the first plate needs any type of geometry like these basic cubes with all used colors on them. Just like before, we can export and extract the 3MF file. This time we have one G-code file for each plate. Now we just erase everything in the plate 1 file and then copy the other plates in as many times as we want. You can also erase the other plates after that. The rest of the process is exactly the same as before. Thank you to my subscriber Leon for showing me how this works. In this case, we can even see the separate print sequence due to the different coordinates of the models. When sending these prints, just select the respective AMS slots for the filaments. We are finally done with the automation setup, but I did promise this would be easy. So let's do a quick recap on how to actually use this. First, we select the automation profile. Then correctly position all models and choose the right self-release settings. I'll explain that in a minute. Make sure you have the correct push-off height in the end G-code. For small parts, modify the safety clear for a side push-off. Export the sliced model and unzip it to open the .g-code file. In there, we can slightly increase the extrusion for the first moves, and then loop the print like I just showed. Now just rezip and rename the file to send it to the printer. Once you understand how this works, this whole process is very easy and the setup takes only a few minutes. Our automated printer can now run continuously without part pick-off. But please pet your printer from time to time, because it does such a good job and might feel a little lonely without your attention. Before we continue with advanced tricks for efficiency and easy part self-release, let's look into Printago, the automation solution for print farms and perfect sponsor for this video. I quickly show you how it works, what I tried out and what I think about it. Due to their cloud slicing, the setup for Bambu printers is way easier than I expected. You can just import all your Bambu settings and printers with a few clicks. Even our printer automation profiles can be used here. Parts can then be added from geometry files or from 3MF files with advanced slicer settings. Slicer profiles are then assigned to these parts. Prints can then be started from here, and with the quantity selected will be added to the print queue. These are automatically distributed on available printers. You can always see which prints are in progress, completed, or show an error. Stopping prints and changing the print queue is also possible. You can even enable their Fabmatic mode to automatically restart prints, which completely eliminates the 3MF unpacking and all the print looping that I showed earlier. I absolutely love that feature. Looking at the roadmap, lots of new features are on the horizon as well, and I have tried out some of these already, with more to come. But what I like most is that they are completely free for personal use and fairly priced for businesses. Overall, they get a big thumbs up from me, and I can highly recommend trying them out. But now let's talk about the science of parts self-releasing from the bed. Some PLA brands, like this PLA from Bambu Lab, stick incredibly well on the standard PEI sheet, almost too well for safe self-releasing with standard settings. But why? On a heated bed, various types of adhesion forces hold the print to the surface. But when the print and bed cool down, the plastic shrinks around 6 times more than the PEI sheet. If the shrinking forces are high enough, the bond between print and bed weakens or even breaks, leading to self-release. So for better self-release, we can decrease the bond strength and increase the shrinking forces. For less bed adhesion, I recommend increasing the Z offset in the printer start G-code. This is done near the end using the G29.1 command. For the matte PLA, we can also lower the bed and nozzle temperature for the first layer in the filament settings. Decreasing the first layer line width helps additionally. Don't overdo it with these settings, or your prints won't stick anymore. Increasing the shrinking forces is a more interesting approach. We can do that by adding one of these yellow modifiers for the first few layers. Just right-click the part and select a fitting shape. In the resized modifier, we can increase the infill percentage and then select any type of linear pattern for high internal stress. Thick infill lines also help. The additional infill in the bottom area will increase the shrinking forces and help with self-release. This little test shows that the part with linear infill releases significantly easier than the one without. This works even better for large prints. I don't recommend going over 40% infill, as this might lead to warping on some parts, like shown here. Compared to other PEI sheets, the standard Bambu PEI sheet is rougher, which in my experience leads to slightly lower self-release temperatures. G10 build plates are supposed to self-release better, but with the shown settings, I don't need them and still always use the standard PEI sheet. And don't worry about printing hundreds of parts on the same spot without cleaning the bed in between. Bed adhesion only decreases due to your oily hands when you touch the build plate. If you do clean it once in a while, use a fresh sponge and dish soap. None of that isopropyl alcohol. Then completely rinse it off with water afterwards, like Bambu Lab recommends as well. But what about efficiency? Printing one egg cup with a cooldown phase of 40 minutes leads to 47% printer downtime. Not good. Printing 4 egg cups at a time is a lot better already, with only 18% printer downtime. Printing a whole bed filled with egg cups is the most efficient solution, but riskier should any print problems arise. A full bed can also lead to messy push-offs. Let's take it to the next level and reduce the cooldown by adding an external fan to the setup for a few bucks. The A1 series has a free AMS port, which we can use with a 24-volt fan. My fan uses only half of the indicated current, just to be safe. In addition to the fan, we need a little button to turn it on, because the AMS port sadly can't be accessed with G-code. This button conveniently has the AMS plug at one end and the fan plug at the other end. I again quickly designed a button holder, in which we can insert the body and hold it in place using 2 screws. This whole part can then be attached to the top of the A1 Mini by reusing the standard screws. A little button extender is glued on as well. Now we'll just add the fan to my printable stand design with 2 screws. Then plug everything together to complete the setup. Next up is adding some code to press the button before cooldown. We just need to add 3 move commands for that. First move to the maximum Z height, then press the button and move away again. Now when the print is done, the extruder head will press the button like intended and turn the fan on to help with the cooldown. Perfect. By the way, this move is not enough to cut the filament. After the cooldown phase, we add 2 more move commands. This will turn the fan off and move back to a safe position for push off. Let's quickly take a look at both lines in action. I absolutely love it. To not hit the button holder during the AMS filament cutting, we'll move the AMS command to the end of the clearing sequence. After the command to restore the full Z current is a good spot. For safety, we will make sure that the extruder is close to the bed with the G1 Z move command. The M104 nozzle heat command is needed for the following filament switching commands to execute. You can also add the M104 command earlier to save some time. Now just turn the hot and off again and we are done. Do not use this for multicolor AMS prints above 165 mm. This will hit the extruder, and we all know that's printer abuse. Adding this fan reduces the cooldown time by 3 times, all the way down to 13 minutes. From a business perspective, the small downtime or even 40 minutes are completely worth it, as your own time is the most valuable resource you have. This whole fan thing is optional, but I only paid €8 for it. All files and hardware links are in the description. Finally, you could also remove the bed insulation for an even faster cooldown, but this would increase energy usage during printing. I don't recommend doing that. Try automating your own printer and comment below if this video has helped you out. Click here for more videos like this one, and thank you for watching.